Imagine standing on a world where the sky is dominated by a wall of striped clouds 40 times larger than the full moon. A place so quiet, so frozen, that time itself seems to have stopped 4 billion years ago. For decades we looked at this moon and saw a perfect, unremarkable ball of ice. We called it Europa. We told ourselves it was a dead relic, a frozen wasteland orbiting a giant that would eventually swallow it whole. But we were wrong. We weren't looking at a moon, we were looking at a mask. And in the last 18 months, the James Webb Space Telescope didn't just take a picture of that mask, it watched the mask slip. What it found hiding in a region called Terra Regio isn't just chemistry, it's a bulletin from a hidden basement that has no business being active. The story we've been told about our solar system just broke, and it broke because of a stain seeping through the frost. Europa has been lying to us for decades. We looked at this moon and saw a smooth ball of ice, pretty in photographs, but unremarkable in every way that should have mattered to a serious scientist. It was the kind of world you talked about politely, the way you might look at a colleague's vacation photos. Interesting, but ultimately something to move on from. From the outside, it looked like a cracked egg, a white shell crisscrossed with reddish-brown streaks that stretched for thousands of kilometers. We knew there was an ocean down there. We had suspected it since the late 1990s when the Galileo spacecraft detected a magnetic signature that could only be explained by a vast, conductive body of liquid. But for 20 years, that was the end of the story. We were stuck outside, pressing our faces against frosted glass, unable to taste the water or see through the ice. We were left with a hypothesis, a promising candidate for life that remained safely locked away behind 30 kilometers of frozen armor. But the James Webb Space Telescope has changed the nature of that silence. It didn't drill through the ice and it didn't land a probe, but it did something far more disruptive. It began reading the damaged messages written on the surface. To understand why this changes everything, you have to understand the forbidden shoreline. For a long time, the scientific consensus was that Europa was a static world, a frozen fossil where the ocean and the surface rarely, if ever, communicated. We treated the ice shell as a permanent wall, but Webb's near-infrared spectrograph, an instrument so precise it can identify molecules from 600 million kilometers away, found a fingerprint that shouldn't be there. In a geologically young area of disrupted terrain known as Terra Regio, Webb detected a concentrated hoard of carbon dioxide. This wasn't a thin dusting scattered by random meteorite impacts from the outside. It was localized, intense, and sitting exactly where geological models say the moon is refreshing itself from below. The lead researchers were stunned because the distribution pattern pointed in only one direction, downward. The carbon wasn't arriving from space. It was seeping through the fabric of the moon like a stain. This was the first real evidence that the ocean isn't just sitting there, it is talking to the surface. And what it's saying is unsettling. We are no longer looking at a quiet, predictable cosmos. We are looking at a moon that is actively exchanging the chemistry of a hidden sea with the vacuum of space. This discovery effectively drew a massive X on the map, transforming Europa from a promising mystery into a compelling crime scene. For years, the world watched Webb deliver images of newborn stars and ancient galaxies, each discovery safely contained within what we believed the universe was supposed to be. But when Webb looked closer to home, at the edge of what we call the habitable zone of our own solar system, the data stopped fitting. It revealed that Terra Regio isn't just a scar on the ice, it's a surface laboratory where the hidden ocean is leaking its secrets. The frozen wasteland we thought we knew has been replaced by a world that is geologically alive, perhaps even more active than Earth in its own strange way. Scientists spent nights working on this raw data, staring at pixels that represented the first chemical clues of an alien interior. They realized that the carbon dioxide they were seeing is unstable on Europa's surface because of the intense radiation from Jupiter. If it's there now, and in such high concentrations, it must have been placed there recently in geological terms. This means the communication web court is happening now. The ice hasn't just cracked, it is breathing. We have moved past the era of polite observation. We are now in the era of the detective, where every new spectral line is a piece of testimony from a world that has finally decided to stop keeping its secrets. This is the frosty lie that has finally been exposed. We thought we had plenty of time to wonder about Europa, but Webb has shown us that the internal origin of this carbon makes the search for life an urgent spatial reality. We are no longer guessing if the ingredients for a biosphere are there. We are looking at the place where those ingredients are currently being served to the surface. The realization that the ocean is chemically accessible from orbit has frozen the scientific community in a state of constant awe. We are no longer looking at a distant, pretty dot in a telescope. We are looking at the forbidden shoreline of an alien sea, and for the first time in history, we can actually see the footprints of what's happening in the dark. If we were to treat the surface of Europa like a map of a cold, silent crime scene, then Terra Regio is the blood spatter on the floor that tells you exactly where the struggle happened. To the untrained eye, it looks like a mess, a jagged, jumbled collection of ice blocks, tilted at impossible angles and frozen into a chaotic slurry. Scientists call this chaos terrain, a name that perfectly captures the sense that something violent and energetic happened here recently. But for the James Webb Space Telescope, Terra Regio wasn't just a mess, it was a destination. For decades, we had a fundamental problem with Europa. We couldn't tell if the things we saw on its surface belonged to the moon itself, or if they were just cosmic trash left behind by passing comets and meteorites. When we found salts or dark streaks, the skeptics could always argue that they were delivered from the outside, like dust settling on a parked car. But the data Webb sent back in late 2023 ended that debate with a single, sharp spectral line. It found carbon dioxide, and it found it in a way that changed the geometry of our search. The carbon wasn't evenly distributed like a thin layer of frost. It was heavily concentrated, heaped up almost exclusively within the borders of Terra Regio. This is the Terra Regio fingerprint, and it is the first solid evidence of what scientists call an internal origin. To understand why this is such a breakthrough, you have to realize that carbon dioxide shouldn't even be there. On a moon as heavily bombarded by Jupiter's radiation as Europa, CO2 is notoriously unstable. It breaks apart, it vanishes. If you see a massive concentration of it sitting on the surface today, it means it was put there recently in geological terms. It didn't arrive on a slow boat from a distant comet millions of years ago. It was pushed up, forced through the ice from the dark, pressurized world below. Think of the ice shell not as a wall, but as a carpet. For years we've been looking at the surface, trying to guess what the floor underneath looks like. What Webb found at Terra Regio is the equivalent of a dark, damp stain seeping through the fabric from the basement. You don't need to lift the carpet to know there's a leak. The stain tells the whole story. As Geronimo Villanueva of NASA's Goddard Space Flight Center noted, the distribution of this carbon was consistent with material welling up from the interior. We aren't just looking at a moon, we are looking at a moon that is bleeding its internal chemistry into the vacuum of space. But why Terra Regio? Why this specific broken patch of ice on Europa's trailing hemisphere? This is where the story gets unsettling. Terra Regio is geologically young. In a solar system where most surfaces are billions of years old and scarred by ancient craters, this region looks like it was paved yesterday. The chaos terrain is a graveyard of ice blocks that have been shattered, rotated, and refrozen. The leading theory is that warm ice, or perhaps even liquid water, rose up from the deep ocean, softened the shell from beneath, and caused the surface to collapse and reassemble in a disordered state. It's a place where the moon's hidden basement actually touched the sky. When the Webb teams analysed the spectral data, they didn't just find carbon, they found it mixed with the same kinds of salts we find in our own oceans. Things like sodium chloride and magnesium sulfate. This isn't just a random assortment of chemicals, it's a signature. It's the signature of a salty, mineral-rich sea that is in active communication with its environment. This realization turned Terra Regio from a point of interest into a surface laboratory. We no longer have to imagine what the ocean floor might look like. We can start to infer its chemistry by reading the damaged messages written in the ice of this one specific region. The debate on Reddit and in scientific circles immediately ignited. For years, there was a divide between the thick ice and thin ice camps. The thick ice supporters argued that the ocean was buried so deep, 30 kilometers or more, that nothing from the bottom could ever reach the top. They saw Europa as a world in permanent lockdown. But the Webb discovery at Terra Regio has forced a massive re-evaluation. If carbon from the ocean is reaching the surface in such concentrated bursts, the lockdown is over. Whether the ice is thin or there are brine pockets trapped just a few kilometers down, the result is the same. The ocean is accessible. This discovery effectively drew a massive X on the map. Before Webb, we were looking at Europa as a global mystery, a puzzle where every piece looked the same. Now we have a target. Terra Regio has become the geographic centerpiece of the search for life. It is the place where the forbidden shoreline is thinnest. If we ever send a lander to Europa to scoop up a sample of an alien sea, we now know exactly where to land. We wouldn't be landing on a moon, we'd be landing on a bridge built of shattered ice that connects our world to a dark, saltwater abyss that has been sealed away for 4 billion years. But as we zoom in closer on this stain in the ice, a new and more complex question begins to emerge. If the carbon is coming from the ocean, what else is coming with it? Carbon is the backbone of life, but life also needs energy. And on a moon where no sunlight ever reaches the water, that energy has to come from somewhere else. The Terra Regio fingerprint told us that the ingredients are there, but it also hinted at a much darker, much more violent process. Because while the ocean is leaking upward, something else is being pushed downward from the surface, something that might be the only reason life on Europa is possible at all. We are no longer just asking if Europa is habitable in theory. We are looking at a specific location where the moon is actively showing us its cards. The detection of carbon dioxide at Terra Regio wasn't just a data point, it was a revelation of active exchange. It proved that Europa is not a static, frozen relic of the past, but a dynamic, circulating system. The frosty lie of an impenetrable shell has been replaced by the reality of a leaky world. And as we prepare to send the Europa Clipper to taste those ice grains for itself, we have to face the possibility that the stain we found is just the beginning of what the ocean is trying to tell us. The scientific community held its breath in March 2024. For years, the narrative surrounding Europa had been building toward a single, spectacular image, a giant, shimmering plume of water vapor erupting from the southern pole, screaming into the vacuum of space. We wanted a spectacle. We wanted the smoking gun that Saturn's tiny moon, Enceladus, had already given us, a moon that acts like a cosmic fire hose, constantly spraying its internal ocean into the sky for anyone to see. But when the James Webb Space Telescope turned its massive gold-plated eye toward Europa to confirm these eruptions, it was met with a deafening, icy silence. No massive jets, no persistent towers of vapor, just the same frozen, cracked egg we've been staring at for decades. This wasn't just a disappointment, it was a paradox that threatened to derail the living ocean theory entirely. If the ocean is truly active, and if the ice is truly cracking, where are the geysers? To understand why this silence is actually more terrifying than a loud eruption, you have to look at the ghosts in our data. Back in 2012, and again in 2016, the Hubble Space Telescope caught what looked like faint glows of oxygen and hydrogen at the very edge of the moon's disk. These were the phantom plumes, detections so shaky and so right at the limit of Hubble's vision that they launched a decade of scientific civil war. Some researchers staked their careers on them, while others dismissed them as digital noise or artifacts of Jupiter's intense magnetic environment. When Webb, an instrument hundreds of times more sensitive than Hubble, failed to find them, the skeptics felt vindicated. But the intermittent window theory suggests we aren't looking at a lack of activity, we are looking at a lack of synchronization. This theory posits that Europa doesn't speak in a constant stream like Enceladus. Instead, it speaks in short-lived, localized episodes. It is a moon of moods and moments. We are like detectives who keep arriving at a crime scene 5 minutes after the witness has stopped talking. The intermittent window means the moon only reveals its interior during specific, violent tidal stresses, brief windows when Jupiter's gravity kneads the moon's core like dough, forcing the internal pressure to a breaking point. Think about the sheer scale of the forces at play here. Europa is caught in a gravitational tug-of-war between Jupiter and the other massive moons, Io and Ganymede. As Europa moves through its slightly elliptical orbit, it is stretched and squeezed by millions of tons of gravitational force. This tidal heating is what keeps the ocean liquid, but it also creates a massive amount of internal pressure. On Enceladus, that pressure has found a permanent vent, a safety valve that never closes. But on Europa, the ice shell is a vault. It is a pressurized container 30 kilometers thick. For a plume to escape, it has to overcome a level of structural resistance that we can barely imagine. The missing plumes tell us that Europa is a world of containment. It suggests that the carbon we found at Tara Regio didn't get there through a simple, easy spray. It was pushed through a convective process, a slow churning movement of warm ice rising from the depths, dragging the ocean's secrets to the surface in geological bursts. We have been waiting for a geyser, but Europa is giving us a leak. We wanted a dramatic explosion, but the reality is much more subtle and perhaps much more significant. The fact that Webb saw no plumes during its observation window in 2024 doesn't mean they don't exist. It means we caught the moon in a state of lockdown. This creates a haunting narrative for our search for life. If Europa only reveals its heart in intermittent bursts, it means our missions, like the Europa Clipper, are in a race against time and luck. We are trying to catch a whisper in a hurricane of radiation. The intermittent window theory reframes the entire mission as a game of planetary hide-and-seek. We know the ocean is there because of the magnetic signatures Galileo found in the 90s. We know the chemistry is there because of the carbon web found in 2023. But the missing plumes prove that we are still standing outside the vault, waiting for the tumblers to click into place. There is a deeper, more unsettling layer to this silence that the original outlier videos completely missed. If the plumes are sporadic, it means the communication between the ocean and the surface is episodic rather than continuous. This has massive implications for the dead ocean theory. If the ocean only communicates with the surface once every 1,000 years, or only in tiny localized spots like Tara Regio, then the exchange necessary for life might be too slow. Life needs a constant flow of energy and nutrients. If the intermittent window is too narrow, the ocean might be a chemically starved graveyard where the ingredients for life exist, but the disequilibrium needed to power it has long since faded away. This is the central mystery of the missing plumes. Is the silence a sign of a dead world, or is it the silence of a pressurized system waiting for its next outburst? We are no longer just looking for water, we are looking for the rhythm of the moon. We are trying to understand the heartbeat of a world that only shows its true face when it's under extreme duress. The 2024 Webb data was a reality check. It stripped away the easy optimism of the constant geyser and replaced it with a much more complex, high-stakes detective story. Humanity's observations keep arriving between the most important events. We are looking at a palimpsest, a surface that has been rewritten over and over by radiation and ice. The missing plumes aren't a failure of our technology, they're a character trait of the moon itself. Europa is a moon that keeps its secrets guarded behind a wall of ice and a mask of radiation. And while we were busy looking for a fountain of water, we might have missed the most dangerous part of the story. Because while the ocean is struggling to get out, something else is being forced in. Something from Jupiter. Something that turns the lethal radiation we've been fearing into the very thing that might be keeping the ocean alive. To understand the true nature of what James Webb has uncovered, we have to stop looking at Jupiter as a planet and start seeing it for what it actually is: a celestial particle accelerator. If you were to stand on the surface of Europa, you wouldn't just be standing in the dark. You would be standing in a horizontal hailstorm of subatomic lead. Jupiter's magnetic field is so massive and so violent that it traps electrons and ions, whipping them around the moon at nearly the speed of light. Every single day, the surface of Europa is bombarded with 540 rem of radiation. To put that in perspective, that is enough to kill a human being in a matter of hours. It is a world that is being constantly, relentlessly sandblasted by a wall of death. For decades, this radiation was the no-go zone. It was the reason we couldn't stay, the reason our electronics would fry, and the reason we assumed any life on the surface would be sterilized in minutes. But the James Webb data has revealed a paradox that turns this nightmare on its head. The very radiation that makes Europa's surface a graveyard might be the only thing making its ocean a cradle. This is what we call the radiation pipeline. And it is the most sophisticated piece of the Europa puzzle that the mainstream headlines completely ignored. The Webb telescope didn't just find carbon at Tara Regio, it found it coexisting in a strange chemical dance with hydrogen peroxide and crystalline ice. In any other environment, finding hydrogen peroxide would be a footnote. But on Europa, it is the smoking gun of a planetary life support system. When those high-energy particles from Jupiter slam into the ice of the surface, they don't just bounce off. They act like microscopic scalpels, performing a process called radiolysis. They literally rip the water molecules apart, splitting the H2O and forcing the atoms to recombine into new, highly reactive compounds, specifically molecular oxygen and hydrogen peroxide. On the surface, this is a destructive force. It chews through organic molecules, turning them into simpler chemical fragments within decades. It bleaches the moon. But this is where the peroxide conveyor theory changes everything. If Europa were a static, dead world, that oxygen would just sit on the surface, useless and frozen. But we know from the Tara Regio fingerprint that the ice is moving. The surface is being swallowed and replaced by the ocean below in a constant churning cycle. Imagine the surface of Europa as a giant solar panel, except instead of collecting light, it's collecting chemical potential from the radiation belt. Every hour that the surface is exposed to Jupiter's wrath, it is being charged with oxidants. It is becoming a chemical battery. And through the chaotic, broken terrain of places like Tara Regio, that battery is being plugged into the ocean. As the irradiated ice is sucked back down into the interior through subduction or convective churning, it carries that concentrated oxygen and peroxide with it. This is the missing link for life in a sunless world. Down in the deep ocean, 100 kilometers beneath the ice, there is no sunlight for photosynthesis. There is no way for plants or algae to create the energy that drives an ecosystem. Without a source of oxygen or oxidants, the ocean would eventually become chemically starved, a stagnant, dead sea, where the ingredients for life are present, but the spark is missing. The radiation pipeline provides that spark. It is a top-down delivery service that takes the lethal energy of Jupiter and converts it into metabolic food for the depths. Webb's detection of these chemicals sitting exactly where the ocean is breaking through the crust suggests that this conveyor belt isn't just a theory, it's an active, ongoing process. We are watching the moon breathe in a way we never expected. It inhales the radiation from Jupiter, processes it into chemistry, and exhales it into the ocean. It is a feedback loop that connects the most violent environment in the solar system to what might be its most delicate biosphere. But there is a dark side to this revelation that the optimists rarely talk about. For this pipeline to work, the intermittent window we discussed has to be open. The exchange has to be fast enough to matter. If the ice shell is too thick, or if the subduction of the surface takes millions of years, the chemical charge might dissipate before it ever reaches the water. We are looking at a race against time. The dead ocean theory suggests that if the circulation is too slow, the ocean becomes a chemical graveyard where the battery runs dry faster than Jupiter can charge it. This is why the specific location of the Webb discovery is so haunting. Tara Regio isn't just a random spot, it's a surface laboratory where we can see the conveyor belt in action. The presence of crystalline ice that hasn't yet been fully disordered by radiation, proves that this material was placed there very recently. The crime scene is fresh. The moon is currently speaking to the radiation belt, and the radiation belt is answering back. As we look at the data, we realize that we've been thinking about habitability all wrong. We've been looking for Earth-like conditions, sunny skies and calm seas. But Europa is something far more alien. It is a world that thrives on the very thing that should destroy it. It has turned a lethal obstacle into a life-giving resource. It is a moon that lives in the shadow of a monster, using the monster's own breath to stay alive. The forbidden shoreline isn't just a physical place where water meets ice. It's a chemical boundary where the energy of the cosmos meets the mystery of the deep. And according to the newest Webb observations, that boundary is far more porous than we ever dared to hope. But as we begin to understand how the radiation pipeline feeds the ocean, we have to confront a new, even more disruptive possibility. Because if the surface is cycling downward to feed the deep, then the ocean might not be as deep as we think. We might be looking for life 100 kilometers down, when the real story is happening much, much closer to the surface. We might be looking at lakes in the Attic. For decades, we have looked at Europa through the lens of a simple, binary world. There was the surface, a frozen, irradiated wasteland, and there was the ocean, a dark, pressurized abyss hiding 100 kilometers beneath the crust. We treated the ice shell like a solid, impenetrable vault door, a 30-kilometer thick barrier of frozen armor that kept the two worlds separate. In our minds, the only way to reach the secrets of the deep was to drill. We imagined massive nuclear-powered thermal probes melting their way through the basement floor to finally reach the water. But as the James Webb data from Tara Regio began to sink in, scientists realized they might have been looking in the wrong place. The X on the map isn't just a location, it's a depth. And it turns out, the ocean we've been looking for might be much closer than we ever dared to imagine. This is the shallow reservoir theory, and it is the most disruptive shift in planetary science since we first confirmed the ocean existed. It suggests that Europa isn't just a two-layer cake of ice and water. Instead, it's more like a sponge. Webb's discovery of concentrated carbon dioxide in the chaotic, jumbled terrain of Tara Regio has forced us to reconsider the internal architecture of the moon. If that carbon is coming from the deep ocean, how did it get through 30 kilometers of solid ice without a massive, visible plume? The answer lies in the attic. Imagine your house has a basement full of water, but between you and that basement is a massive thick floor. Now imagine that inside that floor, hidden within the floorboards themselves, are hundreds of smaller perched pockets of water lakes in the attic. These are what scientists call melt lenses or brine pockets. They aren't part of the global ocean, but they are born from it. The shallow reservoir theory posits that the internal signals Webb detected aren't coming from the deep ocean 100 kilometers down. They are coming from these hidden reservoirs trapped just a few kilometers beneath the surface. This changes the entire narrative of habitability. For years, the thick ice camp argued that Europa was essentially a dead world because the ocean was too far away to ever interact with the surface. They saw the ice as a tomb, but the lakes in the attic theory provides a middle ground that is both terrifying and exhilarating. It suggests that Europa has a dual occupancy habitability. You have the deep, ancient ocean at the bottom, and you have these perched lakes near the top. These lakes are the waiting rooms for the interior. They are where the ocean chemistry sits and stews before finally breaking through to the surface in regions like Terra Regio. To understand how these lakes form, you have to understand the strange lava lamp physics of Europa's interior. Because of the intense tidal heating from Jupiter, the bottom of the ice shell is constantly being warmed. This warm ice doesn't just sit there, it becomes buoyant. It begins to rise through the colder, heavier ice above it in massive, slow-moving plumes called diapires. Think of them like bubbles in a lava lamp, rising through the crust over thousands of years. As these warm plumes reach the upper layers of the ice shell, the pressure drops and the salt content causes the ice to melt, creating a lens of liquid water trapped entirely within the shell. When Webb looked at Terra Regio, it saw chaos terrain, a place where the surface looks like it was dropped into a blender and then frozen mid-swirl. Under the shallow reservoir theory, this isn't just a random scar. It is a collapse zone. It is a place where one of these lakes in the attic became too large or too heavy for the surface to support it. The ceiling gave way, the surface ice crashed into the hidden lake, and the internal chemistry of that lake was smeared across the landscape. The carbon dioxide Webb detected isn't just a signal from the deep, it's a signal from a localized disaster that happened right beneath the frost. This realization has divided the scientific community into a new kind of civil war. On one side, you have the deep ocean purists, who believe we are seeing the true heart of the moon. On the other, you have the shallow reservoir realists, who argue that we might be looking at a contaminated sample. If the carbon is coming from a perched lake, it might have been sitting in the ice for 1 million years, being bombarded by radiation and altered by the unique chemistry of the shell. It might not represent the living ocean at all. It might be a fossilized version of the ocean's past. But for those looking for life, the lakes in the attic are the ultimate prize. If life exists in the deep ocean, it is forever out of our reach. We will never drill 100 kilometers through cryogenic ice. But if life exists in these shallow brine pockets, just 3 or 4 kilometers down, it is accessible. It is scoopable. The shallow reservoir theory moves Europa from a world we can only dream of touching to a world we can actually sample. It turns the forbidden shoreline into a series of habitable islands hidden inside the ice itself. This is the deeper, unanswered mystery that the mainstream documentaries missed. They talk about the ocean as a single monolithic thing, but the Webb data suggests the ocean is actually a fragmented, multi-level system. We aren't looking for one big sea, we are looking for a labyrinth of water. Each one of these perched lakes could be its own independent experiment in evolution. Each one could be a mini biosphere, seeded by the ocean below, but evolving in the unique, radiation-rich environment of the upper crust. As we prepare for the arrival of the Europa Clipper, the mission's Reason radar has suddenly become the most important tool in our arsenal. Its job is to peer through the ice and find these bright radar reflections that indicate liquid water at shallow depths. If Clipper finds these lakes, it will settle the debate once and for all. It will prove that Terra Regio isn't just a place where the ocean leaked out. It's a place where the attic floor collapsed. We have spent years staring at the frosted glass of Europa's surface, trying to see the basement. But Webb has shown us that the most interesting things might be happening in the walls. The lakes in the attic represent a new kind of cosmic architecture, a world where the habitable zone isn't a planet's distance from a star, but a specific depth within a moon's frozen skin. And as we look closer at these stains in the ice, we have to ask ourselves, if the lakes are there, and the carbon is there, and the energy is there, who is living in the attic? We are no longer just asking if the door is open. We are starting to realise that the house might already be occupied, and we've been looking at the floorboards, while the neighbours are right under our feet. If you could take a drop of Europa's hidden ocean and place it on your tongue, what would it taste like? It's a question that sounds like science fiction, a feat of exploration reserved for a future centuries away. We are separated from that water by 100 million miles of vacuum and a 30-kilometre wall of cryogenic ice. And yet, in the wake of the James Webb Space Telescope's 2023 observations, we have done something almost as impossible. We haven't touched the water, but we have read its salt diary. This is the part of the story that most mainstream documentaries gloss over, preferring to focus on the headline of water while ignoring the specific gritty chemistry that actually determines if that water is a cradle or a grave. Webb's near-infrared spectrograph did more than just map the location of carbon dioxide. It looked at the damaged messages written in the chaotic ice of Terra Regio and found something deeply familiar: sodium chloride. To you and me, that is common table salt. To an astrobiologist, it is a revelation. On most of the moons in our solar system, we expect to find exotic, bitter chemistries, things like sulfuric acid or frozen ammonia. But the salt at Terra Regio isn't an exotic byproduct of radiation. It's a signature of a salty, mineral-rich sea that looks suspiciously like our own. This is what we call the salt diary. When water sits in contact with a rocky seafloor for billions of years, it doesn't stay pure, it becomes a thief. It leaches minerals from the stone, dissolving elements and carrying them into the depths. This process, known as water-rock interaction, is the very beginning of the story of life. On Earth, the salts in our oceans are the biography of our planet's crust. On Europa, the salts smeared across Terra Regio are the biography of a world we cannot see. By identifying sodium chloride and magnesium sulfate sitting alongside the carbon, Webb has effectively allowed us to read the outside cover of the ocean's diary. But the salts tell us more than just it's salty. They tell us about the temperature and the violence of the world below. On Earth, we have hydrothermal vents, places where the cold ocean water seeps into the crust, is heated by magma, and then screams back out into the dark, loaded with minerals. If Europa's seafloor is a cold, dead rock, the salt signal would be weak and uniform, but the concentration Webb found suggests an active exchange. It suggests that somewhere, 100 kilometers down, the water is interacting with the silicate rock floor in a way that creates a specific chemical diversity. This brings us to the white smoker theory. On Earth, we have two main types of vents: black smokers, which are incredibly hot and acidic, and white smokers, which are cooler, alkaline, and rich in the very salts Webb just detected. Many scientists believe that life on Earth didn't start in the sunlit shallows, but at these white smoker vents. If the ratio of sodium chloride to magnesium sulfate on Europa matches what we see in Earth's alkaline vents, it means the moon isn't just habitable in a general sense, it's hosting the exact chemical environment that triggered the spark of life on our own planet 4 billion years ago. However, the diary has some darker pages. This is where the dead ocean theory from our lore vault becomes a haunting possibility. Just because a diary has ink doesn't mean the story is still being written. One of the massive gaps in the common narrative is the question of chemical starvation. If Europa's core cooled down billions of years ago, the seafloor volcanism might have stopped. In that scenario, the salts we see on the surface are just fossilized remnants of an ancient, lively past. We might be tasting the memory of an ocean that was once alive, but has since run out of the energy needed to sustain a biosphere. Life requires disequilibrium. It needs a constant, fresh flow of energy and new chemistry. If the salt ratios Webb found are static, it could mean the Moon is just a giant, frozen chemistry set, perfectly preserved, but utterly still. This is the central tension of the salt diary. Is the salt currently being produced by active vents, or are we looking at the last meal of a dying moon? Webb caught the conversation mid-sentence, but it couldn't tell us when the sentence started. This is why the detection of crystalline water ice alongside the salts in 2024 was so disruptive. Crystalline ice is fresh ice. On a moon bombarded by Jupiter's radiation, ice should be amorphous, its molecular structure shattered into a disordered mess. If the ice at Tara Regio is still crystalline, it means it was placed there so recently that the radiation hasn't had time to destroy it yet. The stain is fresh. The leak is happening now. This changes the way we look at the forbidden shoreline. We aren't just looking at a place where the ocean was. We are looking at a place where the ocean is becoming the surface. The salt isn't just a discovery, it's a coordinate. It tells us that the seafloor and the surface are connected in a grand circulating system that defies every intuition we have about how a moon should work. We are reading the diary of a world that is fighting to stay active against the crushing cold of deep space. Think about the implications of finding table salt on an alien moon. It means that if you were to stand in the chaos of Tara Regio, the ground beneath your boots wouldn't just be ice, it would be a mineral-crusted shoreline, white and reddish-brown, smelling of the sea. It bridges the gap between the alien and the familiar. It tells us that the laws of chemistry that built our oceans are the same laws at work in the Jovian system. But as we peel back the layers of this chemical testimony, we hit a wall. Science can tell us the salt is there, and it can tell us the carbon is there, but it cannot tell us what those ingredients are doing in the dark. In that gap between data and reality, a different kind of industry has formed. While the scientists are debating the ratios of magnesium to sodium, the rest of the world has been busy filling the silence with something else. Because when the salt diary provides a hint of a familiar sea, the human imagination doesn't wait for a peer-reviewed paper to tell it what to think. It starts building its own version of the truth. And as we will see, the rumour economy surrounding Europa has become just as powerful and just as dangerous as the radiation itself. For most of human history, the question of whether life exists beyond Earth was a matter for theologians and philosophers, not for a spectrograph. It was a question asked in the abstract, a dream that lived in the margins of science fiction and the quiet corners of our imagination. But when the James Webb Space Telescope released its data on Tara Regio in late 2023, something strange happened in the digital shadows of the internet. As the scientific community was carefully measuring the concentration of carbon dioxide and salts, the rest of the world was busy building a myth-making machine. In the absence of a definitive answer, the human craving for revelation began to mutate solid science into something far more mysterious and, in many cases, far more dangerous. The clickbait claim that James Webb just found something that changes everything is a perfect example of how the rumour economy functions. It takes a nuanced, high-stakes scientific development, like the discovery of an internal carbon source, and compresses it into a single, dramatic sentence designed to trigger an emotional response. On public social media platforms like Facebook, the solid data from Webb began to transform into a shadow ecosystem of myth and oversimplification. Viral posts started claiming that Europa was sending radio signals directly to Earth, or that the new data practically proved hidden civilizations were communicating with the surface in real time. One particularly persistent myth claimed that these radio signals were getting stronger, a narrative that completely ignored the fact that Jupiter itself is a naturally violent radio source that has been screaming into the void for 4 billion years. This is the rumor economy in action. It is a place where social media's imagination upgrades simple habitability into absolute certainty and telescope data into prophecy. For a world that is physically hidden under 30 kilometers of ice, the discourse surrounding it has become hidden under layers of human interpretation. When the evidence is thin but the desire for a sign is intense, the rumor itself becomes a character in the story. We see this in the way Discord leaks are used as a rhetorical accelerator. Even though there are no credible, verifiable leaks about a secret Europa discovery, the mere mention of a leak frames ordinary speculation as forbidden knowledge, making the viewer feel like they're being let in on a secret that NASA is trying to hide. But if you move away from the noise of Facebook and into the more sophisticated battlegrounds of Reddit, the myths take on a different, more technical form. In subreddits like r/space, Europa has become the centerpiece of a scientific civil war. Here, the myth-making machine isn't talking about radio signals, it's arguing over the thick ice versus thin ice models. Some commenters advocate for Richard Greenberg's older theories of a globally thin crust that allows the ocean to breathe freely, while others point to the newer, more conservative work that favours a thick shell with internal lakes. This debate isn't just about physics, it's about hope. If the ice is thin, the ocean is a neighbour. If the ice is thick, the ocean is a prisoner. The Reddit lore also reveals a deep Enceladus envy. A recurring argument insists that Saturn's moon Enceladus is actually a better candidate for life because its plumes are constant and easy to sample, while Europa remains a quiet mystery. This rivalry between moons shows how we have anthropomorphized these frozen worlds, turning them into competitors in a race to prove that we are not alone. Even the more grounded discussions about serpentinization, the non-biological reaction between water and rock, are often hijacked by the desire for a biological explanation. We want the carbon web found at Tara Regio to be the waste product of an alien biosphere, even when the data more soberly suggests it is the result of hydrothermal vents or radiation processing. This transformation of data into mythology is not just a side effect of the digital age, it is a fundamental part of how we interact with the forbidden shoreline. Because we cannot touch Europa, we have turned it into a Rorschach test for our own expectations. The intermittent window theory is a perfect example. While scientists use it to explain why Webb didn't see a plume, the public imagination uses it to suggest that the moon is hiding its activity from us. It turns a lack of data into a suspenseful narrative, where every minute that the telescope isn't looking is a minute where something extraordinary might be happening. The myth-making machine also thrives on the idea of the discovery that froze the world. We love the idea of scientists lying awake at night, questioning their life's work because a new image challenged the very foundation of cosmology. When Webb looked at ancient galaxies that appeared too mature, too early, the internet immediately latched onto the idea that the Big Bang was wrong, or that the universe was cycling. This same logic is applied to Europa. If the carbon at Tara Regio doesn't fit a simple model, the rumor economy doesn't look for a better model. It looks for a revolution. It wants a story where every single rule of biology is about to be rewritten. But the true deep lore of Europa, the story that the viral posts miss, is that the mystery is becoming more interesting, not because of one magic signal, but because of how multiple, weak signals are converging on the same place. Tara Regio is becoming a location character, a haunted house where every clue, from the salts to the crystalline ice to the carbon dioxide, points back to the same hidden basement. The scientists themselves like Geronimo Villanueva and Samantha Trumbo, are not looking for creatures. They are looking for exchange. They are interested in whether the ocean talks to the ice and whether the ice eventually talks to space. As we peel back the layers of the rumor economy, we realize that the phrase changes everything isn't entirely empty. It's just that the change isn't what people expected. Europa has changed from a generic candidate for life into a spatially specific mystery with one chemically loaded hotspot. It has become a world where the forbidden shoreline is finally being mapped, even if the messages we are receiving are still damaged by radiation and time. The myth-making machine is a reflection of our own constant awe. We are creatures who need to call out through the dark, and when we don't hear a reply, we invent one. We have taken the raw, tricky pixels of Webb's data and woven them into a tapestry of prophecy and conspiracy. But as we prepare to move from the detective story of Webb to the direct testimony of the Europa Clipper, we have to face a chilling reality. What if the silence of the plumes and the dead ocean signals aren't just myths? What if the most terrifying thing about Europa isn't what we might find, but what we might have already lost? Because as the science gets sharper, it's starting to hint at a story that is much darker than any Facebook rumor could imagine. We are no longer just looking at a world that could be alive. We are looking at a world that might be an almost world, a place that had everything it needed for life, but simply ran out of time. There is a haunting possibility that we rarely discuss in the light of day, a perspective that turns the excitement of the James Webb discovery into something much more somber. We have spent this journey looking at Europa as a world of becoming, a place where the ingredients for life are finally being tallied up like items on a grocery list. We have the water, we have the energy, and now, thanks to Webb's eye on Tara Regio, we have the carbon. But there is a brutal law in biology that overrides every ingredient list. The difference between a kitchen full of food and a cooked meal is the fire in the stove. And on Europa, there is a growing, quiet fear among some of the world's most senior planetary scientists that the stove may have gone cold billions of years ago. This is the almost world warning, and it suggests that Europa might be the most heartbreaking place in the solar system. A world that had every single thing it needed for life, yet simply ran out of time. To understand this, we have to look past the headlines and into the grim reality of chemical starvation. Most of the outlier videos you've seen focus on the optimism of the triumvirate: liquid water, energy, and chemistry. They treat these three things as a guarantee, a 99.7% chance that life must be thriving in the dark. But astrobiologists are beginning to grapple with the dead ocean theory. This theory posits that even if you have an ocean 10 times deeper than Earth's, and even if you have carbon seeping through the ice, you still need ongoing, violent disequilibrium to power a biosphere. Life doesn't just need ingredients, it needs a constant, fresh flow of energy and new chemistry to stay ahead of the crushing weight of entropy. On Earth, that energy comes from our sun, or the churning volcanic heat of our core, but Europa is a moon that exists at the absolute mercy of its parent. The almost world warning stems from the fact that Europa's internal heat is not a permanent gift. While tidal heating from Jupiter's gravitational squeeze keeps the ocean liquid, it doesn't necessarily keep the seafloor geologically active. If the moon's silicate core has cooled too much, the hydrothermal vents we've been dreaming of, those white smokers that might have birthed the first cells, may have long since turned into silent, cold stone. Without that active water-rock interaction, the ocean becomes a stagnant, chemically starved reservoir. It is a world that is habitable in principle, but biologically impoverished in reality. We might be looking at a world that is habitable the same way a museum is habitable. The oxygen is there, the temperature is controlled, but there is no one living inside. This changes how we must interpret the James Webb data from Tara Regio. If we are operating under the almost world framework, then the carbon dioxide we found isn't the breath of a living sea, it's a tombstone. It might be the fossilized remnants of an ancient chemical era, pushed to the surface by the slow-dying gasps of a moon that is losing its internal heat. When we see the damaged messages in the ice, we have to ask ourselves, are we reading a live bulletin, or are we reading the final page of a history book? The gap between a world that could support life and a world that does support life is a chasm that we have only ever crossed once on Earth, and we still don't fully understand how it happened. This is the danger of drawing conclusions from a sample size of one. Because life happened so easily and so early on Earth, we assume it is an inevitable consequence of the right chemistry. But the thermodynamic extinction theory suggests that most habitable worlds in the universe may actually be almost worlds. They are worlds that tick every box on our checklists but fail the final test of longevity. If the intermittent window of Europa's geological activity is too slow, or if the radiation pipeline doesn't deliver its chemical food fast enough to the depths, any spark of life that once existed would have flickered out eons ago. We might be arriving at the party 4 billion years late. There is something deeply unsettling about the idea of a sterile ocean. We have been conditioned by science fiction and viral headlines to believe that where there is water, there is a 99.7% chance of life. But the reality Webb is showing us is far more nuanced. It is showing us a moon that is struggling to stay active. The detection of crystalline ice and salts at Tara Regio proves the surface is being refreshed, but it doesn't tell us if that movement is powered by a thriving volcanic interior or just the slow mechanical cooling of a dying moon. We are looking at a world that is in a state of constant awe, but also constant peril. If Europa is an almost world, then the upcoming missions like Europa Clipper and JUICE aren't just exploration missions, they are archaeological digs. When Clipper passes within 25 kilometers of the surface to taste the ice grains with its SUDA instrument, it won't just be looking for amino acids, it will be looking for the disequilibrium that proves the ocean is still breathing. If the chemistry it finds is flat, if it looks like a chemistry set that has reached perfect equilibrium, then we will know the truth. We will know that we are standing on the shoreline of a sea that is chemically dead. This reframes the entire search for life in our solar system. We have spent so much time looking for the ingredients that we have ignored the process. We look at exoplanets like K2-18b and see dimethyl sulfide and think we found the jackpot. But we forget that chemistry can be a cruel liar. The universe is full of creativity, and it can generate the building blocks of life in 1,000 different ways that have nothing to do with biology. The almost world warning is a reminder that we're not looking for a 99% chance of life. We are looking for the rare, fragile convergence of time, energy, and chemistry that allows a world to transcend its own geology. As we look up at the wall of Jupiter from the fractured plains of Tara Regio, the stakes of the 2030s become clear. We aren't just looking for neighbours, we're looking to see if the universe's habitability is a one-off fluke or a widespread reality. If Europa, with its perfect salts, its internal carbon, and its protective ice shell, is a graveyard, then the habitable zone of the universe just became a much lonelier place. It would mean that even when the universe tries its hardest to build a home, it often fails. We are waiting for Clipper not just to confirm our hopes, but to settle this terrifying silence. We are no longer just asking, is there life? We are asking, did we miss the window? And in the answer to that question, the frosty lie of Europa might finally reveal its most painful secret. We have reached the limits of what a detective can do from a distance. The James Webb Space Telescope has given us the fingerprints, the chemical signatures, and a specific X on the map at Tara Regio. It has shown us that the ocean is leaking, that the carbon is present, and that the ice is alive. But as incredible as Webb is, it is still a witness standing 600 million kilometers away. To truly know, If the almost world is a graveyard or a cradle, we have to stop looking and start touching. We have to move from the era of observation into the era of the direct witness. And that witness is a machine built to survive a level of violence that would shred any other spacecraft we have ever created. It is the Europa Clipper, and it represents the most expensive and sophisticated gamble in the history of planetary exploration. To understand the mission of the Clipper, you have to understand the monster it is about to face. Jupiter is not just a planet, it's a lethal, radioactive environment that treats anything in its orbit like a target. As we've discussed, the radiation belt around Europa delivers 540 rem of radiation every single day. If you were to park a spacecraft in a stable orbit around the Moon, its electronics would be fried, its sensors would be blinded, and its memory would be erased within weeks. This is why the Europa Clipper isn't going to orbit Europa at all. Instead, it's going to be a cosmic ghost, living in a massive, elliptical orbit around Jupiter and only dipping down to touch the Moon in 50 high-speed, high-precision flybys. This is where the storytelling of the mission becomes cinematic. Every time the Clipper approaches Europa, it is entering a war zone. To protect its brain, the spacecraft's electronics are encased inside a titanium vault. Imagine a box with walls nearly a centimetre thick, forged from one of the strongest metals known to man. Inside that vault, the mission's computers sit in a silent, armoured sanctuary, while the outside of the ship is sandblasted by Jupiter's radiation belt. The Clipper will scream past the surface at thousands of miles per hour, sometimes coming as close as 25 kilometres from the ice, lower than some commercial airplanes fly on Earth. It will have only a few hours to gather its data before it has to retreat back into the safety of deep space to breathe and beam its findings back to Earth. But it's what the Clipper is carrying into that storm that changes the game. While Webb had to guess based on light signatures, Clipper is carrying an instrument called SUDA, the Surface Dust Analyzer. SUDA is, quite literally, a machine designed to taste the Moon. It doesn't need a massive, spectacular plume to erupt for us to get a sample. Because Europa is constantly being hit by tiny micrometeorites, a faint haze of ice and dust is always being kicked up into space from the surface. SUDA will catch these microscopic grains no larger than a speck of sand, and analyse their molecular composition on the fly. This is the moment the dead ocean versus living ocean debate finally meets its match. If Terra Regio is truly a place where the ocean is leaking to the surface, SUDA will taste it. It will identify the salts, the carbon, and, most importantly, the organic molecules that Webb could only hint at. One single grain of ice caught at 25 kilometers above the chaos terrain could contain the chemical proof of an alien metabolism. We aren't just looking for water anymore, we are looking for the byproducts of existence. If there is life in that dark, salty abyss, the Clipper is the machine that will finally catch it red-handed. While SUDA is tasting the dust, another instrument called Reason will be looking through the floor. Reason is an ice-penetrating radar designed to settle the lakes in the attic mystery. As the Clipper passes over regions like Terra Regio, the radar will send pulses of energy deep into the ice shell, looking for bright radar reflections. If there are perched lakes or brine pockets trapped just 3 or 4 kilometers beneath the surface, Reason will see them. It will map the plumbing of the Moon, showing us exactly how the ocean and the surface are communicating. It will tell us if the carbon Webb found is coming from a deep, ancient sea or a shallow localized reservoir that we might one day be able to land on. The stakes of this mission, which launched in October 2024 and will arrive at Jupiter in 2030, cannot be overstated. We are no longer in the realm of promising hypotheses. We have a target, we have a plan, and we have the titanium vault. The Clipper is the culmination of 30 years of Enceladus envy, and Galileo ghosts. It is carrying the wisdom of the veterans who saw the first grainy photos of the ice cracks in the 90s, and the new ideas of a generation of scientists who grew up knowing that Europa was the most important world in the solar system. But there is a tension in the mission design that we must acknowledge. Because the radiation is so intense, every flyby is a risk. We are operating at the absolute edge of our technological capability. The intermittent window theory suggests that we might still miss the big events. The plumes might not fire while we are there, or the conveyor belt might be in a period of stasis. We are trying to decode a damaged message in the middle of a hurricane. The Clipper is not just an explorer, it's a gambler. It is betting that 50 passes are enough to find the X that Webb marked for us. If the Clipper arrives in 2030 and finds only barren processed salts, if it tastes the ice and finds no trace of the spark of life, the almost world warning will become our reality. We will have to face the fact that a world can have everything and still be empty. But if it finds even a hint of complex organics, or if the radar reveals a labyrinth of water just beneath the surface, then the story of humanity changes forever. We will no longer be a species living on a blue marble in a silent void. We will be a species that knows where the other oceans are. The Into the Titanium Vault chapter of our story is the bridge between our curiosity and our discovery. We have spent decades standing outside the frosted glass, and we have spent the last 18 months reading the Salt Diary from a distance. But in the next few years, we are going to walk through the door. We are sending a machine into the heart of the Jovian storm to ask the ocean a direct question. And as the Clipper prepares to taste its first grain of alien ice, we are all becoming creatures of constant awe, waiting for a message from the deep that has been 4 billion years in the making. We are no longer guessing, we are arriving. We are standing at the end of the beginning. For 400 years since the moment Galileo first saw 4 tiny points of light dancing around a striped giant, we have been guessing. We guessed that Europa was a moon. We guessed it had a shell. We guessed it might have an ocean. But the era of the educated guess died the moment the James Webb Space Telescope's data from Terra Regio hit our screens. What we are witnessing now is not just another scientific update, it is a convergence. It is the moment where geology, chemistry, and the human need to call out through the dark have finally met at a single, specific set of coordinates. The frosty lie of a dead, static world has been permanently replaced by the reality of a dynamic, ambitious, and deeply mysterious ocean world that is practically screaming its secrets into the vacuum of space. This is what it means to move from a promising candidate to a compelling one. Before Webb, Europa was a hope, a 99.7% chance, built on indirect magnetic signatures and fuzzy photographs. Today, it is a research program with a target. We have transitioned from looking for water in general to looking at Terra Regio in particular. This geologically young chaos terrain has become our location character, a haunted house where every clue, the carbon, the salts, the crystalline ice, and the radiation-borne peroxide, all point to the same hidden basement. We are no longer asking if the ocean is there. We are reading the damaged messages it is currently sending to the surface. We are looking at an X on the map that was drawn not by our imagination, but by the moon's own internal circulation. But as we look at that X, we have to reckon with the scale of our own existence. Scientists often talk about the distance to planets like K2-18 Burl, 124 light-years away, as if it were a neighbourly stroll, yet it remains a distance that might forever be beyond our physical reach. We see dimethyl sulfide in the atmosphere of a Hycean world, and we dream of thriving biological diversity. Yet we are still separated by 730 trillion miles of silence. Europa is different. Europa is barely a speck on the map compared to the vastness of the universe. It is the spare room in our apartment. It is the place where the offering of water is not just a spectral signature from a distant star, but a physical reality we are about to taste with the Europa Clipper. The stakes of this convergence are higher than any clickbait headline could ever convey. If Europa is a living ocean, it means that the chemistry of life is not unique to Earth. It means that the universe generates these building blocks wherever the conditions allow. It would mean that we are not a fluke, but we must also face the shadow of the almost world warning. If we arrive at the forbidden shoreline in 2030 and find only a chemically starved sea, if we find that the spark of life never ignited or has long since flickered out, then the silence of the universe becomes even more profound. It would mean that even when a world has every ingredient, the water, the energy, and the carbon, it can still remain empty. It would mean that the jump from habitable to inhabited is the rarest miracle in the cosmos. This is the tension that makes the current moment so electric. We are no longer waiting with hope, but waiting with evidence. The James Webb Telescope has sharpened the target list and narrowed the possibilities, effectively forcing humanity to pause and ask whether the story we've been telling ourselves about the universe is fundamentally incomplete. We are looking at a universe that appears older, more structured, and more continuous than we ever allowed ourselves to imagine. Whether it is the mature galaxies appearing too early in time, or the carbon-rich stains appearing on a frozen moon, the message is the same. Complexity is not an accident, it is a mandate. As the Europa Clipper travels toward its 2030 encounter, it carries more than just a titanium vault and a surface dust analyzer. It carries our constant awe. It is the direct witness that will decide if we are living in a quiet, predictable cosmos, or one that is dynamic, ambitious, and deeply mysterious. When that machine catches a single grain of ice, no larger than a speck of sand, and reads its molecular story, the guessing era of humanity will finally come to a close. We will know if the salt diary we've been reading from afar was a living document or a fossilized memory. We have spent decades staring at the frosted glass, dreaming of what lay beneath. Webb didn't just break that glass, it showed us that the glass is breathing. We have moved from a solar system of cratered, airless rocks to a neighborhood of weird, eye-opening findings where planets can be made of diamonds or have the density of marshmallows. But among all these mind-blowing worlds, Europa remains the most personal. It is the moon that reminds us that we too are made of water. It is the forbidden shoreline that is finally inviting us to step onto its sand. The final chapter of cosmology is nowhere near written, but the chapter on Europa's mystery is rapidly reaching its climax. We have the ingredients, we have the coordinates, and we have the titanium vault. The myth-making machine of social media may continue to churn out stories of radio signals and hidden cities, but the truth being uncovered by the detectives at NASA and the ESA is far more compelling than any fiction. We are no longer guessing if the door is open. We are watching the light from the other side spill out across the ice. One day, perhaps in the 2040s, a lander will touch down in the chaos of Terra Regio. It will melt through the armor we've been studying for generations and lower its eyes into a sea that has never seen the sun. Whatever it finds, whether it is a thriving ocean of biological diversity or a stagnant, chemically starved reservoir, will rewrite our understanding of our place in the stars. But until that day, we have the X on the map, we have the salt diary, and we have the realization that James Webb didn't just give us prettier images, it exposed cracks in the story we thought was settled. The universe has no boundaries in terms of creativity, and Europa is its masterpiece of concealment. But the concealment is ending. The frosty lie is over. We are standing on the edge of the forbidden shoreline, and for the first time in history, we aren't just looking at the water, we are waiting for it to look back.